Welcome back. In the last video, we connected GitHub as our identity provider and proved that every user authenticating through Teleport gets a short-lived certificate tied to their real identity. This is a massive improvement over the default kube configs that you may get from your cloud provider. But we left one thing wide open. The kube access, or whatever role we used, grants system masters typically to everyone who logs in, not too dissimilar to what you get from your cloud provider. And that means that every authentic user has full admin access to the entire cluster, every namespace, every resource, every verb. And when it comes to production infrastructure, we want to focus on the principle of least privilege. That means that every user should have exactly the permissions they need to do their job and nothing more. Overprivileged access is one of the most common root causes in Kubernetes security incidents. An engineer with full cluster admin accidentally deletes the production deployment. The problem is the process, not the developer. A compromised developer laptop gives an attacker keys to every namespace. The problem is the process, not the developer. A contractor who only needs to view logs in a staging namespace can instead access all the secrets in production. Again, the problem is the process, not the contractor. Today, I'm going to show you how to fix the process. We're going to build a two-layer RBAC model where Teleport controls which Kubernetes groups a user certificate carries, and Kubernetes RBAC controls what those groups are allowed to do. We will use Teleport's deny rules to create hard boundaries that cannot be bypassed, even if someone misconfigures the Kubernetes side. Sound like fun? Let's dive in. So the first step is setting up the namespace boundaries. We're going to create two namespaces, development and production. In your organization, you will more than likely have more. And these may be clusters, staging, monitoring, CI/CD, and so on. But for today's demo, I feel two namespaces is more than enough to demonstrate the pattern. So let's take a look at our create namespaces script, which should be no surprise to anyone. This is a script that creates two namespaces, development and production. I feel it's pretty safe just to YOLO this straight in to our cluster. And as you can see, we're continuing with my production cluster from the previous videos. However, you should not be doing this in production. I'm doing it to keep these demonstrations applicable to an almost real-world scenario. So now that we have our namespaces, we now need to create our Kubernetes roles, RBAC rules, that define which each group can do within those two namespaces. And this is where our multi-layer model starts to take shape. Teleport is going to assert which group a user belongs to by embedding it in their certificate. Kubernetes is going to enforce what that group is allowed to do based on Kubernetes standard roles and role bindings. So let's take a quick look at the manifests that we're going to use in the development namespace, where we have a role for viewing that grants read-only access to core resources like pods, services, config maps, etc. Like so. Here we have a Kubernetes role dev viewer. We create this in the development namespace with API groups, resources, and verbs. We have two different rules here. One is that pod services and config maps, we're going to allow get, list, and watch. But then if we move into the apps API group, which is our deployments, replica sets, stateful sets, etc., we have get, list, and watch as well. To make this work, we need a role binding. And here we just say we want to bind the dev viewer role to the teleport group, teleport devs. And then if we take a look at the production side, besides the production namespace being different, we actually are giving them pretty much unlimited access to the core API group and the apps group with all resources and all verbs. And you should notice the intentional asymmetry here, right? Developers get read-only access in the development namespace, but production admins get full access in production. Neither group can touch the other's namespace through Kubernetes RBAC alone, but we can add a second layer of enforcement. Before we proceed, let's apply our Kubernetes RBAC files. To do so, we can run auth2. And this just applies this to our cluster. We have dev viewer and our production. Perfect. So now we have to handle the teleport side. And this is where teleport rule system really shines. A teleport rule does three things for Kubernetes access. It determines which Kubernetes groups are embedded in the user certificate. It controls which clusters and namespaces a user can reach. And it sets hard deny rules to override everything else. So again, let's start with the dev team role and take a look. Under teleport roles, we have dev team role, where we have spec allow. We set the Kubernetes groups to teleport devs. This means that when a user with this teleport role authenticates, their short-lived certificate will carry the teleport dev group. This is not a Kubernetes resource you can query, but it is part of the authentication system, the authentication API. When that certificate reaches the Kubernetes API server, Kubernetes will match it against the role binding we just created and grant read-only access to the development namespace. But we can also set Kubernetes resources to allow access to only the development namespace. Now, this is a teleport level restriction. Even if someone managed to create a cluster role binding in the Kubernetes cluster that granted teleport devs access to all namespaces, teleport would actually still block this request before it reached the API server. Defense in depth. Now, here is the most important part, the deny rules. Under spec deny, we explicitly block all resources in the kube system and production namespaces. Deny rules and teleport always take precedence over all the allow rules. There is no way to override a deny rule with a more permissive allow rule. And this gives you a hard security boundary. Even if someone creates additional teleport roles with broader allow rules and assigns them to the same user, the deny rules will always block access. In this case, to production and kube system namespace. The prod team role follows the same pattern, but in reverse. It grants teleport prod admins group allow access to the production namespace and denies access to kube system. Notice that we also provide a max session time to live of 4 hours instead of 8, because production access should have a shorter time to live to reduce the window of exposure if a certificate should ever somehow be compromised. All right, let's apply these to our cluster. And now we have links to click to gain access to our dev user and our prod user. Now these are just going to be created as local users because I can't fabricate GitHub users, or I could, but I really don't want to. So give me just a moment to set up dev and production users and store their credentials and 1Password. All done. Now in your production scenario, you would of course have these roles mapped to GitHub teams instead. All right, local users will still allow me to show how teleport roles affect your Kubernetes access in the best possible way. So let me start by highlighting something subtle here. The teleport deny rules and the Kubernetes RBAC are enforcing the same boundary from different layers. The Kubernetes role is the namespace scoped, so dev viewer only grants access within development. The teleport deny rule explicitly blocks production. You might wonder why we need both, and the answer, as I said earlier, is defense in depth. If someone creates a Kubernetes cluster role that accidentally grants broader access, the teleport deny rule will still hold true. If someone modifies the teleport role but forgets to update Kubernetes, the namespace scoped rule still holds true. Two independent layers, each capable of blocking unauthorized access on its own. Together, defense in depth. So let's see this in action. We will deploy some sample workloads, just Nginx deployments in both namespaces. Then we'll log in as the developer and see what we can and cannot do. So if we run O4, I've commented out all of the automation that will be available in your script, but this will handle the teleport login for you. Right now, I just want to get our pods deployed to the namespace. If we run kube control, let's start with get namespaces. We'll see we have development and production. We can go to development, get pods, and do the same in production. Now this is as my Kubernetes kubeadmin super root access, which we now want to blow away. I'm going to take away all teleport access. This includes my real GitHub authenticated teleport access that we've seen earlier, and instead log in as our development user. All right, so I spared you the boring TSH login proxy, only this time we used --user. Because this is a local user and not configured through the GitHub connector, we did have to provide the passport and one-time password as our second factor. We can then run tsh kubels, tsh kube login, followed by the cluster name. And this will add the context to our kube config. And we should be able to run kube control config, get context. And we'll see my admin token from earlier and my new teleport token like so. We can then run kube control -n development, get pod. And we can see the pods running in the development namespace. If we try and change this to production, or even kube control get ns, we will get permission denied. Perfect. All right, I've now logged in as our prod user, meaning I can do config, use context, and run kube controls get pod and development, and this should fail. Phew. And if we run production, perfect. So now we have two users with completely different scopes. But let's take a look at that second layer boundary. Teleport protecting us in the event of a misconfiguration at the Kubernetes level. Okay, last demo. Let's run kube control auth. Who am I? I'm now authenticated as root again by switching to my admin cluster. And what I want to do is apply a Kubernetes RBAC, our escalation test with the cluster role binding. This is a cluster role binding that takes our teleport prod admins group and gives it cluster admin. We can then switch back config use context to our teleport user, where we run auth to mi. And that would be expected, but it does just prove that I'm not root in the cluster anymore. So let's try production, get pods. This works, and development or kube system. Denied. And if we take a closer look at these deny messages, it actually says, ask your teleport admin to ensure your teleport role has the right permission. Awesome. So that was a look at using Teleport's advanced RBAC system with defense in depth, giving you a secure, configurable, fine-grained RBAC model for all your Kubernetes clusters. Awesome. We'll see you in the next video.